Now that we know how to do the Z-score, how to get the p-value, remember we talked about that. We know how to get the null hypothesis. We know how to get the alternate hypotheses. We're going to be able to say whether we accept or reject the null hypothesis. Which one do we keep, right? We have a null hypothesis. We have an alternate hypothesis. Which one do we keep? Now we're going to learn how to do this. Now we talk about the one-tailed, the one-sided statistical test. We saw that on our last lecture. Now this parameter, this population parameter, is strictly greater than specified value, right? Or less than if we have the left tail. But we're looking at inequalities. Now the two-tailed, or we call the two-sided hypothesis. The two-tailed, that's when the population parameter it's either larger or smaller than a specific value, but not equal to. So again, when we're using inequalities, the one tail. When we're using that not equal to, the two tail. So here, I gave you guys some values here, the pictures that we saw last lecture. And let me see, let's take a look at here. Right? Let's do an example. So a health journal conducted a study to see if packaging a healthy food product like junk food will influence children's desire to consume the product. So we have junk food, but we put it in a nice packaging. Will people actually be willing to buy it? Fictitious brand of a healthy food product, I'm going to use sliced apples, was packaged to appeal to children. So we're going to give them junk food, but we're going to put it we're going to use apples, but as a junk food, right? We go to McDonald's, we can buy apples. Now, the researchers showed the packaging of a sample of 335 school children and asked each whether he or she was willing to eat the product. So my N, let me write it somewhere over here. N, the number of people in my study is 335. Now the data are summarized. The X crossbar is 3.23. The standard deviation is 2.44. Suppose the researchers knew that the mean willingness to eat an actual brand of sliced apples, which is not packaged for children, is 3. So the actual mean is 3. The null mean is 3. Now find the test statistic. Now here, I want you to do something. I'm not asking you to type it on your homework, but at the side, I want you to do your null hypotheses and your alternate hypotheses. My null hypothesis is that the mean, the average so far is 3. But let's check what if I want to see if the value is greater than 3. So I want to do a one tail. Here, I didn't tell you guys which one I was going to use, but on your homework, I will tell you, check if the mean has been greater than 3. Okay, so now we're going to find our test statistic. Remember the formula that I gave you guys yesterday? My test statistic, I'll do X crossbar minus mu, all of this divided by the standard deviation divided by the square root of n. Remember that one? I gave you guys that yesterday. Okay, so in this case, for this example, I'm gonna go 3.23 minus 3. All of this, my standard deviation is 2.44 divided by the square root of 335. We talk about how to type this on a calculator. Remember, I use parentheses. And I'm gonna grab my calculator. And I'm just gonna go 3. Oh, let me use my parentheses, right? So open parentheses for the top. On the top, I'm gonna go 3.23 minus 3. Close parentheses. Divided by, open parentheses for the bottom. 2.44 divided by the square root of 335. Close parentheses for the square root. Close parentheses because of the bottom. Press equal. I'm gonna round my test statistic, my C-score, I'm gonna round it to 2 decimal places. So let me call it 1.73. So let me come back here. My C is 1.73. So let me write that thing down. My C value, my C scored is 1.73. Now find the p-value. Remember, p-value is my probability that my results happen by coincidence, happen by chance. Okay, so I gave you guys a table before. So I look at my C-score, my p-value, my on 1.73. I see that it gives me 1.73 gives me the probability. You're looking at my result here is 0.4582. Now my p-value, let me subtract this, because remember, coming back to how our probability looks like, our distribution. Here's the half. And then my p-value, my C-score is 1.73, is about here. So it tells me 0.4582 is this space, but my p-value, my p-score is actually this shaded part. So I have to go 0.5 minus 0.4582. That's how I'm gonna get the probability of the shaded area. According to my calculator, because I have my calculator here, I get 0.0418. But it says round it to 3 decimal places. My calculator gave me 4. So I'm just gonna go 0.042. Now, what is the appropriate conclusion at alpha is equal to 0.01? Oh, so now I have to decide whether I accept the null hypothesis, or I keep whether I accept the alternate hypothesis or I keep the null hypothesis. Oh, which one do I get? Okay. One thing I'm gonna do, my p-score, my p-value, and my alpha, I'm gonna compare them. So my p-value and my alpha, I'm gonna compare them. Remember, my p-value is 0.042 and my alpha is 0.01. Which one's bigger? 0.042 or 0.01? Which one is bigger? Do you know? Yeah, p-value, right? All I need to know whether p-value, which one of these two is bigger. I'm gonna reject the null hypothesis. So that means I'm gonna accept the alternate hypothesis if a big if. So again, I'm gonna reject the null hypothesis, which means I'm gonna accept the alternate hypothesis if and only if the p-value is less than alpha. That's not the case here, right? So in this case, I'm gonna not reject the null hypothesis. Remember, I was gonna reject the null hypothesis if alpha was bigger. But in this case, because the p-value is bigger, then I'm gonna choose to not reject the null hypothesis. So I left space here. We can write it down. I'm gonna say do not reject the null hypothesis. Because p-value is bigger, so nope, I'm not rejecting the null hypothesis. Why? Well, there is. I'm gonna just say it. You guys can write it down. Right? There is insufficient evidence. I don't have enough evidence to conclude that the true mean response for all student children is greater than 3. So I'm not quite saying the null hypothesis is true and that is the only truth that exists. I'm just saying I did not have enough evidence. So that's what I call it insufficient evidence to prove the null hypothesis wrong. I was not able to prove the null hypothesis is wrong. So I cannot reject it. Let's do it again. Let's do another study here. I'm not going to read the question because I've read this question a few times, but here my n is 343, right? You guys see my x crossbar. You guys see my standard deviation. Similar to the before. So let me solve for my null hypothesis. So on the side, let me come up with a null hypothesis and the alternate hypothesis. But let's see, the previous question, I checked for the hypothesis to be the mean to be greater than 3, right? So now let me change this on this question. I'm gonna say the null hypothesis, it says that the mean is 3. That's what the null hypothesis says. But now my alternate hypothesis, let me go with the mean not equal to 3. So remember, before I said, well, check for greater than 3, but now check for not equal to 3. Because on your homework, some of them I will tell you check greater than 3, and some of them I'll say check that it is different than 3. Basically, not equal to 3. Okay, so let me find my test statistic first. So in this case, I have to go, because I remember my formula, x crossbar minus mu divided by the standard deviation, which is divided by the square root of n. So in this case, I have to go 3.27 minus 3 over 2.16 divided by the square root of 343. Remember how to type this in. Emphasis. Let me put everything in parentheses. Let me go to my calculator here. So let me clear this out. Let me come back here. It's giving me trouble. Let's see. Let me go to my calculator now. Okay, cool. Let me clear this out. Open parentheses. So 3.27 minus 3, close parentheses. That's the top. Divided by, at the bottom, I'm going to have 2.16 divided by the square root of 343. Close the parentheses for the square root and close the parentheses for the bottom. And I'm going to round this to 2 decimal places. So I'm going to call it 2.32. Okay, so my C-score is 2.32. Based on my C-score, I'm going to get my p-value, my probability of this happened by coincidence. Okay, so I look at my table. In 2.32. We know how to read the table. It gives me 0.4898. But remember, what does this do? Here's my mu. Here's 3. 0.4898 is this space. But I'm actually interested in the shaded part. That's my p-value, my p-score. So let me go 0.5 minus 0.4898. According to my calculator, that is 0.0102. However, that's not quite my p-value yet. That's what I said, however, because I'm checking for not equal to, that means I also have this, right? This right here, it is 0.0102. And then same thing here, 0.0102. That's this shaded area. And I want to combine those two. So basically add them. Or in my case, I'm just going to multiply by 2. So it gives me 0.0204. But I have to do it in 3 decimal places, right? Okay, so I'm going to go 0.020. That's my p-value. Let me write it better. So my p-value is 0.020. Okay. So again, I know my p-value now is 0.020. I know my mu is 3. Which one is bigger? I mean, my alpha. I don't have to check my mu here. My alpha, because what is the proper conclusion for alpha to be 0.10? Okay, so let me do here. Let me write this down. P-value and alpha. Which one is bigger? 0.020 or 0.10? Yeah, alpha's bigger, right? Okay, because alpha's bigger, then I'm gonna reject the null hypothesis. I'm gonna reject it. So I'm gonna say it. I'm not gonna write it, but you guys can write it on your notes. I'm gonna reject the null hypothesis. Okay, my alpha's bigger, so I'm gonna reject the null hypothesis. I have enough evidence, or there is sufficient evidence to conclude that the true mean response for all school children is not 3. I have enough value. I have enough evidence because my p-value is less than alpha.